Okay, this example illustrates how to use corridor surfaces to design a bridge replacement project. So on my screen I've got several views. I've got a 3D view, a plan view, and a profile view. And I've got two alignments that have been set up. One, it runs along the stream, and which is the current one here. You can see there's a stream. And the other one is along a center line of an existing road alignment. And there that is there. So in order to do this project, I'm going to do it in stages. So the first stage would be to remove the road to expose the existing culvert so it can be removed. And to do that, I have entered the profile, several points here, for the excavation which was going to remove the material. And now I want to assign a template which cuts a trench out along that profile line. So to do that, I go first of all into my template editor, and I've got set up a trench template, which is made up of standard eLibrary components, trench 2. And this is a very simple component. It cuts a trench at a specified width and with specified slope angles. If we quickly look at the parameters, there is a horizontal distance from the attachment point, and then there is cut and first cut slope, which is the slope of the bottom. So very simple component. I've got a left side and a right side. I'm going to go ahead and I'm going to assign that component to a station range along my stream. So I go into assign by range, and I'm going to enter here a station range. First I'm going to select the trench cut, then I'm going to enter a station range, let's say 160 to 335, and now I've got nothing happening up to station 160, then a trench cut 160 to 335, and then nothing happening after that. So I'm going to go ahead and do that, and I can come along and we can look at a cross section somewhere in the middle here, and there is our trench cut. Now, part of this example is to introduce the use of corridor surfaces. So the first thing I'm going to do is to create a corridor surface, and that'll be the trench cut, of course. So I'm going to go into corridor options. I'm going to go to reference surfaces, and I'm going to add a new corridor surface, and this is for my stream alignment. So I will choose, let's take subgrade as my template surface that I want, and I'm going to just choose a color here and a line type which matches my subgrade surface. Go ahead, create that corridor surface, and look over here in the 3D view, and you can see what's going on. That station range where I created the trench cut, cut the sections out, and I've gone ahead and created a corridor surface in that area. So that was my first step. Now the next thing I want to do is I want to add a pipe into that station range. So again, I'll go into my template editor. We'll have a look here. We've got a similar template which has got the trench 2 component in it as well, and it's got a pipe component in it, and we'll quickly have a look at the properties of that. So the pipe has a radius, so here we would have a diameter 6 culvert, and then we offset that culvert from the center line of the pipe, so it's offset by 3 feet. This is an Imperial project, by the way. So we've got a 6-foot culvert in a trench. Now let's just go ahead and assign that template. So once again, I go into assign by range. I'm going to choose the CLV, trench with culvert component, and this time I'm going to assign it for a shorter range, 227 to 335. I pulled these numbers out before the demo, and there is our trench with a culvert component in it. Going to go ahead and apply that, and there you can see our culvert is applying in a range of stations here, and outside the range of stations there is no culvert. So yeah, so we've partially assigned a culvert. Now one of the things you probably want to see right away is you'd like to see what the culvert looks like in profile, and to do that I go into profile options, and I'm going to create some reference features which are going to be the top and bottom of the culvert. So I'll click on reference feature 1. I'll choose a projection type, and I'll go and I'll look at the definition of that, and we see here that we have some template codes that we can choose, and I'm going to choose PBL because I know that's the top component. I'll come back to that in a second, and I'm going to choose PTL. PTL, there we go. And then I'll go back to the profile. Again, we have projection options, and I'm going to turn off the symbol for our culvert, and I'm going to give it a blue line type. So what I've done here is I'm using template components, template codes to create reference features, and I'm going to display those reference features in my profile window. So I've got that set up. Let's just go ahead here, and there in the profile window you can see the location of the top of the pipe, and that's controlled by this checkbox here, reference features. And again, if I went in there, there's my PBL and PTL codes. So where did I get those codes from? If you look at the cross section and you hover at the top, you'll notice it's got some template codes. One of them is called PTL, and similarly at the bottom there's other codes, and one of them is called PBL. So that's the shape of my pipe on the profile, and it looks like I should adjust the excavation here a bit, go a bit deeper, so we can get the pipe extending out properly. There we go. So there's the pipe coming out. Of course, you can adjust this iteratively. Now, the next thing I'm going to do is I'm going to create a pipe surfaces. So I'm going to go back to the cross section, and in the area of the pipe, just move in there. I'm going to have a look, and I see that this pipe is a SRF4 surface. So I'm going to create a surface for SRF4. I'm also going to create a surface for the bottom of the pipe, which is SRF12. These are just for visual purposes. I'm not going to use them to do any volume calculations. I'll come back to that in a second. So to do the surface creation, once again I go into options, train surfaces, and I'm going to add a corridor surface, and this time I'm going to go with SRF4. Let's make it blue, and similarly I'm going to add a surface for the bottom of the pipe, add a surface, this is SRF12, and again I'm going to make it blue. There it is. So I've created two new surfaces, SRF4 and SRF12. Both of them are blue. And we'll just have a quick look at that over here in 3D. You can see it's come up rendering those surfaces, and there they are. One of the things I've got to do perhaps is to make them opaque, which is basically eliminate their transparency, set it to 255. This is just for the 3D display. And there you can see the pipe sitting in the trench, and now we want to start looking at maybe earthworks for the road, or the amount of fill material we have to place back in to cover the culvert. So to do that, I'm actually going to create yet another surface, which is going to be the pipe and the trench combined, and that is done again through options. I'm going to go into terrains and surfaces, and I'm going to create yet another surface, a corridor surface, and we'll give this yet another color, and it's going to be the final merge surface. And yeah, let's just do that for a second. Recalculate this, and there is our final merge surface. So you can see it actually goes and includes the pipe, which is what we want, because we're going to fill on top of it. You can see it there in the orange, what it looks like. It comes down, wraps around the pipe. It doesn't go underneath the pipe because it's a 2.5 dimensional surface. It can't do that. So this is an approximation of what the quantity is going to be. It's ignoring the little bit underneath. Now, before I switch to the road alignment to get my quantities out, I'm going to set the properties of our merged surface to include the merged surface into the topo surface. So let's just go ahead and do that. I'll explain a bit more when we get there. So I'm going to turn that flag on, which basically means that after the construction of the stream segment is done, the original ground surface gets updated with the new surface. Now let's switch over. Let's arrange my windows here. Let's switch over to the other alignment, which is the existing road alignment. So I'll click on that so it becomes current. And notice what we've got going on here is that instead of the road daylighting to the existing ground surface, it's going down to the bottom of the trench, which is exactly what we want to do. So if we look through at the cross sections here, out here the road will be basically daylighting to ground, but as we get in further into the culvert area, we've got the excavation daylighting to the road daylighting to the excavation. So to make this a little bit clearer, and of course the quantities will represent this, my fill quantity is going to be just that material above the pipe. So let's get one more visual on this, and again I'm going to create another surface to represent the road. So I'm going to add another surface, corridor surface. This time the default source is road, and let's choose another color for this surface. Let's go with kind of a yellowy color, and just go ahead with that. And there you can see what is happening. So along the main section of the road, nothing is, it's connecting with the existing ground, but in the pipe area where we've cut the trench and placed the pipe, we're getting quantities calculated down to the to the excavated area. And there's a few issues here which I think will go away if I increase my reporting point or decrease my reporting point station. And there you see that exactly fixed it, and we have a finished product, and the volumes will represent the volumes of filling in that culvert area. And of course, in the culvert itself, we could have made the template more sophisticated. We could have put in some riprap or some other engineered materials into our culvert area and gotten quantities from them. So that's it. Culvert replacement using corridor surfaces.